Welcome to MrCScience.com's video on graphing velocity and acceleration. So we've talked a little bit about velocity and acceleration and what's involved with that. So now let's see how we graph those and what information we can get off of that graph. Okay, here we've set up a little graph. On the one side we've got x. X generally stands for distance. Especially here we're going to set it for distance. Maybe I should set that lowercase d. Our distance is in meters. Then across the bottom we got t for time, which is in seconds. So if we start our graph and we're at 0, 0, as we move along, things change. Okay, so what happened here was we started at 0 seconds and 0 meters. After about 1 second, we've gone about 1.5 meters. 2 seconds, we've gone about 3 meters. So, what we can do is we can figure out our velocity based on that. So we know that velocity equals delta v, or change in here. Control Z is your friend. Velocity equals change in distance over time. So, okay, so that's our velocity. So we can figure that out. So at any point here, the graph is angled at a certain direction. So let's take this point between 0 and 2 seconds. So in oops, get my pen back. So in 2 seconds, we traveled 3 meters. So our velocity equals, we went from 0 to 3, so 3 meters in 2 seconds, or 1.5 meters per second. Okay, so that's one way to tell it, just by the graph, but you can also do what's called the slope. You should be familiar with this from, I'm not sure if they covered in algebra or where, but in a graph, slope equals rise over run. So if we show a slope here, our rise was 3 and our run was 2. So rise, we went up 3, and run, we went over 2. So our slope is 3 halves, or 1.5, which equals our velocity. So you can tell from the slope here what's happening. Now here's an interesting point at the very top. So what happened here? At the top, the slope becomes 0. So at 0, if the slope is 0, our velocity is 0. It's at the very top, so we went up and we stopped. And now our slope is going down. So let's take a point from, say, right here to, let's run all the way down to here. Okay, so what's our slope there? Slope is our rise. Well, we went down, so it's negative. Negative 1, 2, 3, 4, 5. We went down 5. Negative 5. What's our run? 1, 2, 3, 4, 5. Over 5. So our slope is negative 1. What's our velocity? Well, our velocity equals our slope in here, so our v should be negative 1 meters per second, and we can confirm that by taking our distance. So we were at 8 meters, or here, I'm doing it backwards again. So distance, delta of d is final minus initial, so our final distance was 3 meters minus our initial distance of 8 meters over our time. Our initial time, or our final time, was 12 seconds minus our initial time is 7 seconds. So 3 minus 8 is negative 5 meters in. 12 minus 7 is 5 seconds, or negative 1 meter per second. So our slope told us our velocity. So our velocity here was 1.5 meters per second. Then we went to negative 1 meters per second. What's the velocity at this point? You should be able to tell me that. If you said 0 meters per second, you're right, because again our slope flattened out. And then we accelerate again. So we went forward, we went backwards, and then we accelerated. Now our overall displacement, or our overall velocity, if you wanted to get for the graph, see how well I can draw a dotted line, would be our overall displacement. So our overall displacement, we went from 0 to 4 meters in our time of 17 seconds. So we'd have 4 meters per 17 seconds. Or, nice thing about physics, you can use a calculator. What's 4 divided by 17 equals 0.24. So overall we went 0.24 meters per second. That would be our average velocity for the entire thing. Here's where average velocity would be kind of interesting. Instantaneous is your slope at any point. Average is what you did entirely, and because we went backwards, that played with that average velocity. So that's how you do slope with distance and time to find your velocity. Let's look how you do it with acceleration. Okay. Here we have a similar graph, but the units are different. On the left side, let me fix that quick. Getting ahead of myself. On the left side, we've got velocity in meters per second. On the bottom, we still have our time in seconds. So this one's a little different. We started at a 0 velocity. We work our way up to 1 meter per second, 2 meters per second, 3 meters per second, all the way up to 8 meters per second. So, and then we drop down to 0 and go negative and then positive again. Okay, so here's a little bit different. So now we're talking about meters per second or acceleration. So let's look at this first one, the slope. We start out at 0 seconds, and by 3 seconds we're doing 3 meters per second. So our slope, oops, let me get the right tool. And I'm going to actually give ourselves a little bit more room to work here. There we go. Okay. So our slope equals our rise over our run again. So our rise, we went from 0 to 3, so we ended up as 3 meters per second as our ending. And we started out at 0 over our difference in our time. Our time, we ended at 3 seconds, and we started at 0. Here, we'll make these sciencey zeros. So 3 minus 0 is 3 divided by 3. We got 1, and our units now are meters per second squared. So our slope is 1, and our acceleration is also 1. So here our acceleration matches our slope. So now we notice the slope changed a little bit. What's the slope from this point to this point? We'll just call it S. Our slope, well, we end here at our rise of 7. And our initial rise is 3. So 7 minus 3 over our time difference of 5 minus our beginning time of 3. Or we've got 4 over 2, or 2, a slope of 2. Well, our acceleration equals our slope, so our acceleration over this period right here, we'll call it A1. A1 equals 2 meters per second squared as our acceleration. So now here's something interesting. What happens right here? Our slope is 0. Does that mean we stopped? No. Our velocity has peaked at 8 meters per second. But we're still moving, but because our slope is 0, our acceleration is actually 0 meters per second squared. We are not accelerating. Now here's a good sciencey thing for you. Now from this point to this point, what happened? Well, our slope is our rise, 5, minus our beginning rise of 8, over our run of 9, minus our beginning run of 6. 5 minus 8 is negative 3. Over 9 minus 6 is 3, or a slope of negative 1. Our acceleration at that point over that time is negative 1 meters per second squared. Now you'll hear people say it's decelerating. Well, in physics there's only acceleration. It can be positive or negative. So acceleration goes here. Now here's an interesting point. What happens right here? So we've got our velocity at that point is 0. But our slope looks like it's about 3 there, negative 3. So it's about, is that right? Yeah, it's about negative 3. So we're decelerating, or we're accelerating negative 3, and then we go the other direction. So now we're going negative velocity. So the car has sped up, slowed down, and now it's going backwards. So it goes backwards for a little bit. It accelerates to negative 2 meters per second going backwards, and then it changes again. Then it decelerates and it goes back again once it crosses this 0. So anytime it crosses 0, at 0 its speed is, its velocity is 0 meters per second. So it's effectively stopped 2 places here, but its acceleration changes. So at this point where we have 0 slope, its acceleration is 0 meters per second squared. Its velocity is negative. So acceleration, its velocity is negative 2 meters per second squared. It's going backwards 2 meters per second, or not squared. 2 meters per second. Remember, squared is your acceleration. Nothing here is your velocity. Hopefully that makes some sense to you. If you have any questions, feel free to drop me a line at mrc@mrcscience.com. Thank you.